Hello, my name is Nick Ingram. Today I'm going to be kind of teaching you how we could transfer this circuit design over to a truth table. So first we set up the variables A, B, and C. We have them going to various AND or gates. And so right here we have B or C. For AND, it's B and C. And then for up here, it's A or B. And then at the very bottom right here, we combine the two with an OR. So that makes B or C, or B and C. And then up here we have that OR. So we're actually going to have the equation x equals A or B. We'll put that in parentheses. Or B or C, or B and C. So you can see how it's a little bit complex. We can't just put this over to the truth table quite yet. We're going to have to simplify it, and we'll do that in a moment. Okay, so here we're actually going to use Boolean algebra to go ahead and simplify this expression. So first we're going to drop the parentheses for A or B, and then we're going to use our absorption property to get rid of that B or BC. So the result from that is going to be B or C in parentheses. We could just go ahead and drop those. B plus B is going to equal 1. And we could just go ahead and negate that. And then we get A plus C. So as you can see, we actually simplify, so then we make our truth tables much easier. We save a ton of pain in the long run from doing this. All right, we're just going to fill out our truth table with our simplified expression. So first we get 0 for A plus C, plus we get 0 for X, A or C, we're going to get 1, B is 1, but that's not included in our expression. And then just all the way down the list. So you can see here that our expression x is actually going to be matching right up with A plus C. And so that kind of proves our simplicity for this. Okay, so now that we got it out of the way, we're actually going to be converting a truth table back to a circuit. So as you can see here, I already really started the equation. This is going to be an SOP form. Basically, we're taking every single one and we're modeling an equation based off of what's true or not. Like for instance, our first part of the equation, that's not A, B, not C. So you can see right here, we would need the opposite of our input, our 0. And then we have 1 right here, which is fine. And then we need the not C in order to produce a 1. So we really just go down the list, we record which gets a result from X, and then we model it right here. Okay, so coming back, we basically simplified our equation right here. We grouped together A, B, we factored that out from both, and then we eliminated not C and C using rule number 6, and then we reduced it right here. AB times 1 is just AB. Then we factored out B. We actually used rule number 10 right here, or my apologies, rule number 11. Because of that not A right there, we get the product of not C, A or C times B, or and B. And then we get the result of AB plus BC. So you can see right here, we're already going to take a quick guess and say that it's a lot more complex to model a circuit up here than the equation right here. So we're going to do that right now. All right, so we are back. I didn't really want to kind of bore you with drawing out my circuit, so here we are. We have our first equation, which is much more complex, versus our A and B, or B and C. So let me walk you through my circuit first. This is going to be our ABC in an AND, of course. This is going to be our A, not B, and regular C, as you can see. And then at the very bottom, we're going to have our not A and not C with a regular B. And so you can see already we've used about 3 not chips, and then we've also used 3 AND logic gates coming out to an OR, and then our result. Over here, we have our 3 inputs, A, B, and C, and then we have 2 AND gates routing over to A and B, and then B and C, and then those go to a single OR chip, and then we're all done. So as you can see, it's very important to simplify our function, or else we're going to just have wires all over the place. We're going to use chips, resources, efficiency, and that will cost us time and more energy. So really, you can see the purpose of simplifying our equation.